a brief description of what we, as a consultant, what we do before I get into what's on the slide at the moment, is we conceive design solutions. We start with a blank sheet, so it's quite a difficult start for us. It's not something that we pick up. There's not an idea already in place, so it's quite a difficult starting place. We've developed the engineering design solutions, provide a coordinated services design. We assist the architect and client to realise their vision, and provide models and documentation to the contractors at the end of that process. What we need to do, from a consultant's point of view, is we need to do further training. We need to get our engineers engaged with the model, because as Warwick's described, the plant objects we're going to place within the model are going to have parameters which the CAD team can put some information in, but we need the engineers to be involved and start to build and add to those parameters. And later the contractors will do much more of that. We also need to remove ties to traditional delivery methods. At the moment, it's all very much based on 2D drawings, and we need to get away from that. And we've just started a project in the last month where we're actually discussing not issuing any drawings. We're going to give the contractors models, and the model will contain all the data that they'll require. The slide that's on the screen is basically saying I feel that IPD is quite an important maybe project change. We need to engage with the contractors much earlier, to leave it with the consultants who provide a model which provides a consultant's model solution maybe doesn't suit the contractors. It needs to be a better product. So we need to get the contractors engaged much earlier, and we also need to inform the clients what benefits they're going to get from having a BIM model earlier. Again, software interoperability, that's a big issue. We deal with TSI, we've got REVIT, we've AutoCAD MEP, we've got MicroStation, we've got, well, in total we've got 900 packages at the moment within ARUP, and it's a lot, and all these packages try and talk to each other, and we need help from the likes of Autodesk, etc. How does it all start? Well, we start with a client concept. They've got obviously an idea within their head what they want. The architect's providing visual images and PDFs, sketches, Google SketchUp. Structural teams involved, they need to make sure the thing can be built. And typically lots of meetings at this point, and be very, in fact I don't think there'd be any CAD involvement at this point. It's purely meetings and a lot of sketches. The concept is developed in conjunction with the architects, the service engineer, the structural teams, and the client. It's all sketches, PDFs. Like I say, CAD's not engaged at this time. We may start to talk about services, strategies, zoning, and these are the type of sketches that we would perhaps get from the architects, our engineer internally, often written in sort of Chinese or Japanese, can't quite make out what they're saying. And then we get these sorts of sketches, and we need these earlier from the engineers. We need to make sure that they're thinking about what they're going to provide us. When we get to beginning the design, it's obviously an evolvement from step one. We tend to go with simple shape to represent plant items. CAD may be engaged. There's a bit of reluctance because I think CAD's gone through a transition from tracing and gone back to a technician who actually knows what it is that they're drawing. And again, there'll be lots of options at this point. This is a typical example, just boxes to represent where the plant items are going to be placed. The horizontal and vertical distribution is not individual pipes and ducts, it's an air zone or a pipe zone or an electrical route. All this just helps the architects to understand risers. Risers are often a problem. And if we can get involved early enough and provide a model like this, it just helps, because a picture tells 1,000 words. And these models are very quick and easy to do. You know, an engineer comes up with an idea for a riser. We can knock out a quick 3D model. You know, you're looking at an hour's work to do that, prove that it works, that the service you can get out of the riser. Step 3 would be more spatial planning. Again, it's an involvement. Service routes and strategies are agreed. I know the engineers and the CAD are starting to get involved and starting to collaborate. And we're starting to knock out models like this. In Revit, we're setting up the sheets, setting up the schedules. All this is important, because the other thing I'm trying to encourage engineers to do is not check drawings. In fact, on this job, we're trying to ban paper. We want them to go into Navis, into Revit, to look at this information for themselves. Stop relying on paper, because it's not strictly true. As we go along, it's just adding more layers, it's adding more detail. So now we're modelling all the services, the pipe work, the duct work, the electrical systems. Plant items are now more accurately sized. The blocks may be being replaced, and this is an appropriate time to start using the BIM-MEPAUS consents and families. You may have used them in the step previous, in step 3, but still with a consultant, I think it would still be generic consent, because we don't know the manufacturer, we don't know it's going to be a Holyoke piece of equipment or whoever. So it tends to be generic, and it's the contractor, I think, who'll swap these items out. Coordination, I've slipped it in as step 5, but obviously that's taking place all the way from 2 to 5. We've got to ensure accurate coordination with the structure and the architecture. And one of the things I've had to learn in my short time here in Australia, in the UK we model all the services in one go. Over here we had a team that do the mechanical, the electrical, the hydraulics. I'm trying to adopt the approach we've got back in the UK, where we're actually modelling everything. So the hydraulics, well, the electrical guys now have taken and put him on hydraulics, and he's got to learn that. And they're quite happy to do that. And they're getting an appreciation of how difficult it is to get all the services into a space. Plant items are property fields which may be empty. Well, some of them will be populated, but there'll be a lot of empty fields ready for population by you guys as you get our models. A typical sort of structural model, you can see the detail they go into. That's out of a Revit model. They're showing all the rebar in there now. This is a project we've just issued, and this is a fully coordinated model. We've got the structure, MEP services, fire. The bigger mission is architecture. Architecture just very rarely comes to the table. Again, typical office floor, coordinated solutions using, like that. Again, that's all services to prove something fitted in an existing building. And then we get to the step 6, which is the point where we hand the files over. We hand over to the contractor the DWGs, the Revit files, PDF schedules, everything. We're not going to hold anything back. Because we need to ensure that everything that we've done isn't wasted and just discarded. And I think that's quite an important part of the process. Don't be frightened of handing your stuff over. Just make sure that what you have done is of a reasonable quality. So you're going to get all the schematics, our layouts, everything's within the Revit file. Which shows some 3D views to help visualise what's actually happening on plan. And these are just immediate, all these are free, falling out of the back of the 3D model. And in summary, I think what the BIM-MEPAUS team are offering is actually a very, very good solution. Just need to be agreed objects, robust, well built. For us, the family's maybe not too complex, because we don't want complex objects at this point in time. And the transition from consultant to contractor workflow, the improvements in that feature alone is just worth its weight in gold, again, in my opinion. We must stop redrawing and help and improve the workflow, work together, and ultimately come up with a cradle-to-grave solution, because there's just such a lot of waste out there. And I'll hand you over to Albert. Thank you very much.
Right, my name's Albert Watson. I'm a mechanical service contractor. I'll just give you a mechanical service contractor perspective on why we need a specialist perspective on why we need standardisation and what we're doing to implement the standardisation of model content. Like Duncan and ARUP and other consultants and contractors, we've been modelling for many years, but we've been doing this in isolation. The Americans call this lonely BIM. With the lonely BIM, you've got your own in-house libraries. I'll just explain for the people who haven't done modelling, our models put together. A building model is made up of many thousands of mini models, which we call content, and these contents are stored in libraries. A family of content is used to model a system. So we've got model content, and this is the area that we need to standardise. In the past, we've been modelling, and we've had our in-house libraries, which have been good, expensive to produce, and many thousands of libraries have been produced, all not standardised. So if a consultant like Duncan produced a model, we take that model, because we couldn't use his library because it wasn't a standard library, we swap that model out and remodel it using our libraries, which was very expensive in both time and cost. Now, the BIM-MEPAUS steering committee realised this was a problem quite a few months ago, and decided they needed to change this and get agreed standards. And to do this, they decided to form work groups to achieve it. They assigned me the job of forming a pipe and duct work group, which we got together to produce these standards. This is the actual work group. As you see, it's a group of people representing the industry. We've got consultants, Norman Young, we've got contractors, Triple M, we've got software providers, and suppliers. All these people are working in the coalface. They're the people that are producing the models. They're the people that are actually need this standardisation. Al's a model manager for Norman Young, and Mitchell and Morgan are model managers for Triple M, who are a contractor. Jeff is the software provider for Rcadman, and Brian, CSI, David with the Hasty Group, and Ian and myself are from we're model providers for Watson Fitzgerald, and Brett was a supplier from Tyco. We all got together to actually standardise the modelling process, to actually come with a standard. The first thing we had to do was what we call like the housekeeping side of modelling. This is like it's simple, but it's very important, like the set out and dimensioning of the model, the representation of duct and pipe for insulation and fire rating, the units of measure you use, the line weights and thickness and colours. Now, this is very important because when you produce a model, you're working within the model. It's very clear. It's very easy to read. But you try and, if you produce a PDF or a a paper drawing from that, which you're going to give to site. If it's not modelled correctly in the right line weights and colours, it's difficult to read. It's got no definition. It's very difficult to read. So it's very important to when you start your model to get the right line weights and thicknesses and get a full representation. If you use the standard that we've produced, you'd end up with a PDF. This is a typical, this is for a mechanical service, so the duct and the pipe for mechanical service is emphasised, and you see the architecture is faded out in the background. It's got, denotes the heights of the ducts and the heights of the pipe, and the hatching for the insulation in this case. So this is a typical, if you like, a drawing that could go to site from a model using that standard. Now, if that standard wasn't used, the model's so complex you would not be able to read a drawing, and so it is very important to get those things correct. The other aspect that we had to do was to develop a standard for the content. What I said before, the mini models, the little mini models that are placed in libraries in families to actually build the full model. Now, we've identified, in this case it's a ducting system, and there are about 15 to 20 items which would produce 95% of the ducting systems. And what we've done is develop the rules and standards for these fittings that the software provider reuses to develop the mini model. When he uses these standards, that means then this model can flow through the BIM process. If a consultant uses the BIM-MEPAUS standard, then we can take that consultant, as a contractor, take that consultant's model and install and manufacture it. I'll just go through a typical sort of workflow and show you what the actual concept, how it actually works. In a typical workflow, in the early stages of the workflow, we got a concept design model software and preliminary costing. We got then the detailed design. It goes in detailed design, detailed costing software, and then we have construction model software back into the manufacturer, ducting software, and manufacturing pipe back into. Now these can all be different software platforms. With the BIM-MEPAUS, a fitting could flow through that workflow and without remodelling. In the past, we'd take a conceptual design and it'd be remodelled in the detail. We'd take it again and we remodel it for manufacturing. It was very time-consuming and very costly. I don't know how quite this works, but I've got some links. How do the links work? Not quite sure how it actually works. The mouse on it. Just bear with us for a second. I don't think it works. There we are. No, it doesn't work. Sorry, oh, you are. Oh, there we are. Okay, so this is. I've just taken one of those duct fittings, and this is taken it. This is taken from the conceptual, and all that duct fitting, that model, all it needed was a size, some spatial, no other detail required for that fitting. Could you go to the next one, whoever's working the mouse? Could go back to the workflow, thanks. Maybe I'll do it here. There we go. And could you click on to number 2, thanks. Right, this is that same model, that same bit of fitting. This is this mini model, that bit of content. And here in the design stages, we've got the duct material, the airflow, the fluid type, the velocity, the K factor, which designers would know, and the fishing pressure loss. These are all the design data that's attached to that model. Now, it's the same model that's gone from conceptual to no design. It's with the BIM-MEPAUS, it's not had to be remodeled. It's the same item, but it's now got design data attached to it. Could you now flick on to back to the workflow on number 3, thanks. Again, that same bend, it's just that fitting. This is the costing side of it. Again, all the data required for costing is attached to that model. Doesn't have to be remodeled for the cost planners. It's the same model, only it's now got costing data attached to it. Now, could you go to number 5, thanks, in that workflow? Okay, same model again, but now we're into the manufacturing. It's now flow through manufacturing, same fitting, and now we've got the pattern development out of the sheet metal to actually manufacture it. So you can see that if you go back to the workflow again, thanks, just the workflow. And so you can see with the BIM-MEPAUS standard in place, we can go from conceptual design right through to manufacture without remodelling. And that's the initiative that the AMTA are trying to achieve with the BIM-MEPAUS system, that to implement BIM so we can go right through the process without having to redraw the models. So it is very important for us, certainly as manufacturers and contractors, to implement this system. So thank you very much.